Hello students, today I'm going to discuss about associated angles. Here is some problems of class 11. I've also actually provided the theory part. Hopefully you watched that video. And now I'm going to proceed with some problems on associated angles. So first I'm going with some minor adjustments here. Then I'm going to start the problem set. Okay, so associated angles. And the problems, first problem is find the value of sine minus 480 degree. Sine minus 480 degree. You know that sine within bracket minus 480 degree, that will be minus of sine 480 degree. Now you need to break 480 degree as a multiple of 90, nearest multiple of 90. That will be 90 into 5 plus the adjustment part, that is 30 degree. Now this is an odd multiple, and we all know that trigonometric ratio is going to change here. That will be cos of 30 degree. Now 90 into 5 plus 30. What will be the last position here? The position will be 90 into 4, that is 360 degree, then 90 into 1 again, that will be 90 into 5. And after that, plus 30. 90 into 5 plus 30. So, the the ray is lying in second quadrant, and in second quadrant sign is always positive. So that's why that will be plus of cos 30 degree. Hence minus plus makes it minus cos 30 degree. And the value of cos 30 is always, we know that cos 30 is equal to root under 3 by 2. So the answer will be minus root 3 by 2. Very easy problem. Then the second problem is something like tan within bracket minus 1755 degree. 1755 degree. Just using the formula that tan of minus theta equals to minus tan theta, we will get minus of tan 1755 degree. Then you need to convert this angle into a multiple of 90. After dividing 1755 degree by 90, we will get 90 into 1, that is 90, 5, then 8, then again a 5. In that case, 9 times 810, 90 into 9, 810, and the remainder will be 45 degree. So that will be 90 into 19, 90 degree into 19 plus 45 degree. 90 degree into 19 plus 45 degree. Here, this is an odd multiple, and trigonometric ratio is gonna change here, and it will be cot 45 degree. Now, in which quadrant this is lying? This is 90 into 4, then again 90 into 4, that is 8 rotations, then again 12 rotations, then again 16 rotations are there. After that, 19 rotations completed, then 45 degree. So the ray is lying in fourth quadrant, and in that case, fourth quadrant tan is always negative. So the result will be minus of minus cot 45 degree. So minus minus plus, that is cot 45 degree. Now we know that the cot 45, value of cot 45 is always equal to 1. Hence the answer will be 1. After that, we'll move on to the next problem. The problem number 3. Problem number 3 is cos 1755 degree, and that is 1755 degree. We are going to divide it by 90, and the result will be 90 into 1, that is 90, 5, 8, the same result, and it is 810, and that will, the remainder part will be 45 degree. So that will be cos of 90 degree into 19 plus 45 degree, plus 45 degree. Since this is an odd factor, so trigonometric ratio is going to change here, and that will be sine 45 degree. And from the previous problem, I've already gained the fact that this total angle lies in fourth quadrant, and in fourth quadrant cos is always positive. So the result will be plus sine 45 degree, hence the result will be 1 by root 2. So that's our problem. After that, next problem, fourth problem, cos of 330 degree, cos of 330 degree. Cos of 330 degree will be cos 360 degree minus 30 degree. You may write this one this way. So cos of 360 is 90's even multiple, that is 90 into 4 minus 30 degree, and 90 into 4, we know that trigonometric ratio is not going to change, so that will be cos of 30 degree, cos of 30 degree, and in fourth quadrant, because this is lying in fourth quadrant, in fourth quadrant cos is always positive, hence the result will be plus cos 30 degree, and that will be root under 3 by 2. So the problem solved here. So that's some basic problems here. Then we are going to move on to the next problem, that is our problem number 5. In problem number 5, it has been given that cot 690 degree, cot 690 degree into cos 780 degree, cos 780 degree plus cos 1050 degree, cos 1050 degree, and after that into sine 480 degree, into sine 480 degree. So what will be the calculation part here? This is also very easy. Cot 690 degree. 690 degree means 90 into 7 plus you are going to adjust it with 60 degree. After that cos 780 degree. That is going to be 90 into 8 plus 60 degree, right? After that cos 1050 degree. You are going to adjust it with 90 into 12 minus 30 degree, right? 90 into 12 means 1080 degree, and from that angle we are going to subtract 30 degree, and that will be 1050 degree, and into sine 480 degree. Sine 480 degree will be 90 into 6 minus 60 degree. 90 into 6 minus 60 degree. Hence, here it is an odd multiple. So trigonometric ratio is going to change here, and that will be tan 60 degree. Okay. Cot 90 into 8 plus 60. Trigonometric ratio is not going to change here, and that will be cos 60 degree. Plus cos 90 into 12 minus 30 degree. Trigonometric ratio is not going to change here. That will be cos of 30 degree. And here sine 90 into 6. Trigonometric ratio is not going to change here. That will be sine 60 degree. Now we need to calculate the sines here also. This angle is lying in fourth quadrant, and in fourth quadrant we all know that the sign of cot is always negative, so that will be minus tan 60 degree. And here this is cos 60 degree. Cos 60 degree, this angle lies in first quadrant because 90 into 4 is a full rotation, then again a 90 into 4 full rotation, after that 60 degree. So the angle lies in first quadrant, and that will be always positive. We all know that, na? Add sugar to coffee. That was the rule. That is all-sine-tan-cos. All is in first quadrant, sine is in second quadrant, tan is in third quadrant, and cos is in fourth quadrant. So according to that rule, that will be plus cos 60 degree. After that, 19 to 12 minus 30 degree. Surely this is going to be in fourth quadrant, and in fourth quadrant cos is always positive, so that will be plus cos 30 degree. And this is going to be in 90 into 6, that is 90 into 4 full rotation. After that, 90 into 2, again a half rotation. So minus 60 degree. The angle going to end up in second quadrant, and in second quadrant that is always positive, so that would be plus sin 60 degree. Now minus tan 60, we all know that that is minus of root 3, and cos 60 is known as 1 by 2. Cos 30 is root 3 by 2, and sin 60 is also root 3 by 2. Hence the result will be minus root 3 by 2 plus 3 divided by 4. So the calculation will be something like this. The total LCM will be 4 here, minus 2 root 3 plus 3. So final result will be 3 minus 2 root under 3 divided by 4. That's our final answer. So again, moving on to the next problem, that is our problem number 6. Problem number 6 is, it is given that tan 25 degree equals to A. Tan 25 degree equals to A. It has been given. You need to prove tan 155 degree. Tan 155 degree minus tan 115 degree divided by 1 plus tan 155 degree, 1 plus tan 155 degree into tan 115 degree. That is equals to 1 minus a square divided by 2a. That we are going to prove here. Okay. So the LHS part we are considering here, and that will be tan 155 degree minus tan 115 degree, total divided by 1 plus tan 155 degree into tan 115 degree. And here tan 155 degree will become tan 180 minus 25 degree, and that is going to be tan 90 degree plus 25 degree. That's our 115 degree. Now this is going to be 1 plus the same thing, tan 180 degree minus 25 degree into tan 90 degree plus 25 degree. Now we all know that tan 180 degree minus 25, that is minus of tan 25. Why it is minus tan 25? Because it is the multiple of 90 into 2, and 2 is an even number, so that's why tan not going to change here, and it lies in second quadrant, and in second quadrant always tan is negative, so that's why that will be minus tan 25. And in second quadrant same thing that will happen here. The sign will change here, because say in second quadrant sign of tan is always negative, so that will be minus of cot 25 degree. Why it is cot 25 degree? Because there is a multiple of 90, that is 1, and 1 is an odd number, so that's why trigonometric ratio is gonna change here, and in that case 1 minus of tan 25 degree into minus of cot 25 degree. So in that case that will be minus of tan 25 plus cot 25, total divided by 1, minus minus plus makes it plus, tan 25 into cot 25, we all know that that is 1. Now the value of tan 25 has been given A, so that will be minus of A, plus cot 25 has been given as 1 by A, because tan 25 is A, so you all know that cot theta is always equal to 1 upon tan theta. So if tan theta equals to tan 25 equals to A, then definitely cot 25 will be 1 by A. We all know that. So this is 2 in denominator part, and the result will be minus of A square plus 1 divided by A into 2, that will be 2A. So the total result will be 1 minus A square divided by 2A. That was the proof actually. So that was the process. Now we are moving on to the next problem, that is our problem number 7. In problem 7, it has been given that cot 90 plus theta, cot 90 degree plus theta, cot 90 degree plus theta into sec 270 degree plus theta, sec 270 plus theta, and then sine 180 degree minus theta, sine 180 minus theta. After that, dividing it with cosec minus theta, cosec of minus theta into cos 270 degree minus theta into tan 180 degree plus theta, 180 degree plus theta. Now look at this one, cot 90 degree plus theta. What will be the value here? We all know that that will be minus of tan theta, because 90 plus theta lying in second quadrant, and in second quadrant cot is always negative, so that's why that will be minus tan theta. Sec 270 plus theta, that will always be cosec theta, and that's going to be positive because the angle lying in fourth quadrant, and in fourth quadrant cos and sec is always positive, and 270 is the odd multiple of 90, so that's why cosec theta. And here sine 180 minus theta, sine 180 minus theta, definitely it will be sine theta, divided by cosec minus theta, that will be minus cosec theta. We all know that sine of minus theta, cosec of minus theta, all comes with minus sine theta and minus of cosec theta. Cos 270 minus theta, that will be sine theta, but a minus will be added before it, because that the angle 270 minus theta is in third quadrant, lying in third quadrant, and in third quadrant cos is always negative. Similar in case of tan 180 plus theta, that will be tan theta, and it will be positive because 180 plus theta lying in third quadrant, and in third quadrant tan is always positive. So tan theta actually cancelling out here, tan theta cancelling out, cosec theta is cancelling, and sin theta is cancelling. So the ultimate result will be minus 1 in the numerator part, and in denominator part that will be 1. So the total result will be minus of 1. So that's our problem actually. Again, we are going to move on to the next problem. That is our eighth problem. Eighth problem is something like this. Show that 3 into sine power 4 3 pi by 2 minus x, 3 pi by 2 minus x, plus sine power 4 3 pi plus x, minus 2 sine, 2 within bracket sine power 6 pi by 2 plus x, pi by 2 plus x, plus sine power 6 5 pi minus x is independent of x, is independent of x. Now what is the meaning of that phrase? That is independent of x means we are going to simplify this one, and we will get a result something like this, which is independent of x. That is, there will be a result which is not containing term x, and that is what we are going to prove here. Here 3 into sine power 4 3 pi by 2 minus x. We all know that that is going to be minus of cos x, because 3 pi by 2 trigonometric ratio is going to change here, and it is in third quadrant, so it will be minus cos x whole power 4. And in case of 3 pi plus x, 3 pi plus x means this is our pi, this is again a pi, that is 2 pi, then again a pi, that is 3 pi, 3 pi rotations, and then plus x, that is the angle is in third quadrant, and in third quadrant that is always negative for sine. And trigonometric ratio is not going to change here, because pi is actually an even multiple of 90 degree. So that's why 3 pi is by default an even multiple of 90 degree. So that is going to be minus sine x whole power 4. Now look at this one, minus 2 into sine power 6 pi by 2 plus x. Pi by 2 plus x lies in second quadrant, and that's going to be changed here. Cos x will be the result here, and sine is positive, so that's why cos x power 6. And in this case, sine power 6 5 pi minus 6, that will be sine 5 pi minus x. Sine not going to change here, sine x will happen here, and 5 pi minus x, meaning that is 2 pi, that is also 2 pi, 4 pi, 5 pi. 5 pi minus x, that is the angle is lying in second quadrant, and in second quadrant we all know that sine is always positive, so that will be plus sine x whole power 6. Now we are going with the calculation. Cos x power 4, that will happen, that will be sine x power 4, and in this case that will be cos x power 6, and in this case that will be sine x power 6. Sine x power 6. So we are applying some algebraic formula here. Cos square x plus sine square x whole square. Cos square x plus sine square x whole square minus 2 cos square x into sine square x. Just carefully look at it. This is our cos power 4x plus sine power 4x. If you just expand it, this one, you will get the line here. Okay. Now for this one, we are going to apply a cube plus b cube formula, and the result will be cos square x plus sine square x whole cube minus 3 cos square x into sine square x into, in same line, cos square x plus sine square x. This is in same line, huh? So cos square x plus sine square x, you all know that is going to be 1 minus 2 cos square x into sine square x, 2 cos square x into sine square x. After that, minus 2 into, that is also going to be 1 minus 3 cos square x into sine square x, and that is also 1. So the total result will be 3 minus 6 cos square x into sine square x. 3 cos square x, 6 cos square x minus sine square x, and from this one that is going to be minus 2 plus 6 cos square x into sine square x. Now 6 cos square x sine square x is cancelling each other, and 3 minus 2 is always equal to 1. So we are getting a result with the simplified value is here 1, and 1 is independent of x. So the obtained result or obtained value is independent of x, because there is no x actually. So that's why the total expression is independent of x. So that was the problem actually. Very easy problem. You just need to follow those basic rules here, and then you need to apply or implement some algebraic formula here. Here you are going to you need to apply the formula a square plus b square, and in case of this you need to apply a cube plus b cube formula, and you will get the desired result. That is 1, and 1 is not containing x, so that's why the total expression is independent of x, and that was the proof actually, required proof actually. So hence the problem has been proved here. After that, we are moving on to the next problem. That is our ninth problem. Ninth problem is something like 4 theta equals to 11 pi. 4 theta equals to 11 pi. Then find the value of sine minus theta, sine of minus theta, then plus cos of minus theta, total divided by sec theta plus tan minus theta. You need to find that value. Okay. So from the given result, we can say that 4 theta equals to 11 pi. Hence, theta will be 11 pi total divided by 4. 11 pi total divided by 4. And you can write this one in this way, 3 pi minus pi by 4, right now. 3 4s are 12 pi minus pi, that will be 11 pi by 4. Now, sine minus theta, that is minus sine theta according to the rule. According to the rule, that will be minus sine theta. Cos of minus theta will be cos theta. And you all know that sec theta, okay, no problem. Tan minus theta, that will be minus tan theta. So, if you put the value of theta here, that will be sine 3 pi minus pi by 4. And here you will get cos of 3 pi minus pi by 4 divided by sec 3 pi minus pi by 4. And here also the same thing will happen. Tan 3 pi minus pi by 4. Now, sine 3 pi minus pi by 4, that is going to be minus of sine pi by 4, and the total angle is lying in, just need to draw that diagram here, that is pi, that is 2 pi, and that is 3 pi. 3 pi minus pi by 4 will lie in second quadrant, and in second quadrant sine is always positive. So that's why that will be minus sine pi by 4. And in case of cos 3 pi minus pi by 4, so one thing is sure, we are sure about the fact that 3 pi minus pi by 4 is lying in second quadrant, and in second quadrant cos is always negative, we always know that. So that will be minus cos pi by 4. After that, divided by, that will be also minus sec pi by 4, and in this case that will be minus of tan pi by 4. Okay, now what will be the result here? Sin pi by 4 means sine 45 degree, and that will be 1 by root 2. Cos pi by 4 is always 1 minus 1 by root 2 here, and sec pi by 4 is our root 2, and tan pi by 4 is 1. So the total result will be minus 2 divided by root 2, because 1 by root 2 makes it 2 by root 2, and here that will be minus root 2 plus 1. So after cancelling the minus, we're getting root 2 divided by root 2 minus 1. Root 2 minus 1. So that's our actual result. You may rationalize this one. So root 2 into root 2 plus 1. Root 2 into root 2 plus 1 divided by root 2 plus 1 into root 2 minus 1. In this case, root 2 into root 2 plus 1, total divided by 2 minus 1 will happen, and the final result will be 2 plus root 2 makes it 2, root 2 into 1, that will be root 2. So total result is 2 plus root 2. So the value of total expression is 2 plus root 2 here. So that's our problem actually. Now we are going to proceed with our next problem, that is our problem number 10. And in problem number 10, it has been given that tan alpha minus beta, this is equals to 1. And the second one is given something like sec alpha plus beta equals to 2 by root 3. Equals to 2 by root 3. Find the smallest positive value of alpha and beta. Positive value of alpha and beta. That's our problem actually. Okay? So here actually, if we write tan alpha minus beta, the basic problem is something like this. Here it has been given 1, and we all know that that is equals to tan pi by 4. So if you write alpha minus beta equals to pi by 4 here, and sec alpha plus beta, this is equals to 2 by root 3. 2 by root 3. Now alpha plus beta definitely going to be 30 degree, that is our pi by 6. Now the problem is subtraction here, subtraction minus of two angle, subtracting two angles, and we are getting pi by 4, that is 45 degree, and we are adding these two angles, we are getting pi by 6. Definitely after solving those values, after solving for alpha and beta, we will not get the positive value of alpha and beta. We may get some negative value for beta, or may get some negative value for alpha here also. So actually that will not satisfy the given condition. So that's why I'm going to change this one. Now, tan alpha minus beta, just look at it, tan alpha minus beta is equal to 1, we all know that, and we all know that tan is also positive in third quadrant. So, in this case, we may write this one as pi plus pi by 4, right? Pi plus pi by 4. You may write that thing also. So, tan pi by 4 is always equal to tan pi plus pi by 4. So, that will be tan 5 pi by 4. 5 pi by 4. So, there's another problem because you are considering difference of two angle as 5 pi by 4 and you are considering alpha plus beta equals to also pi by 6. In this case, the same thing will also happen here. Negative value will arise. So that's not going to, we're not going to entertain this one also. So this one will not happen also. We are going to proceed with some another thing. Look at this one. Okay, whatever. We are going to proceed it with this one, 2 by root 3. Now look at this one. Sec is, we all know that sec is positive in fourth quadrant, and in fourth quadrant the value will be, we all know that 2 by root 3, the principal value is pi by 6, and in fourth quadrant that will be sec pi 2 pi minus pi by 6. That is sec pi by 6. Now from this one it will be 6 to 11, 12, 12 minus 1, that will be 11 pi by 6. So that will be 11 pi by 6. So alpha minus beta is equals to 11, alpha plus beta equals to 11 pi by 6. Now we are going to get some meaningful value here. Alpha minus beta equals to pi by 4 and alpha plus beta equals to 11 pi by 6. And 11 pi by 6 means that is actually 330 degree and this is actually 45 degree. So if we add these two equations, we will get 2 alpha equals to 330 plus 45, that will be 375 degree. Hence alpha will be, after dividing 375 by 2, we will get 187 of 1 by 2 degree, right? 187 of 1 by 2 degree. Yes, that's the value. That will be the value here. And from this relation, we are going to get the value of beta here. That is 187 of 1 by 2 degree minus beta. This is equals to 45 degree. Hence, beta will be 187 of 1 by 2 degree minus 45 degree. Now, what will be the value here? That will be 375 by 2 minus 45 degree. And the result will be 375 minus 90 total by 2. And the value here 17 minus 9, that will be 8, and the carry is here equals to 1, and 3 minus 1 equals to 2. So 285 by 2, that will be 285 by 2, that will be 142 of 1 by 2 degree. 142 of 1 by 2 degree. So value of alpha is equals to 187 of 1 by 2 degree and value of beta is equals to 142 of 1 by 2 degree. That is the actually smallest possible value, smallest positive value of alpha and beta we can find here. Okay. No other relations are satisfying here, because if you add these two relations, alpha minus beta equal to pi by 4 and alpha plus beta equals to pi by 6, you will get, this is, look at this one, this is 30, this is 45 degree and this is 30 degree. So we're getting 75 degree. So, okay, 2 alpha equals to 75 and alpha will be 37 of 1 by 2 degree. But in case of beta, what will be the value of beta here? Beta will be minus 7 of 1 by 2 degree. No, that's not possible, because we have to find the smallest positive value of alpha and beta. And when we have written that tan alpha minus beta equal to tan pi by 4, that was, I think I have wrote that one, tan 5 pi by 4, right? Tan 5 pi by 4, that is 225 degree. So if alpha minus beta equals to 225 degree and alpha plus beta equals to 30 degree, you will also get the negative values of beta here. So actually that will not be the result here. Okay. So in case of this problem, you need to adjust this one. That's alpha plus beta, and that's 2 by root 3. 2 by root 3, you all know that that will be sec pi by 6. And you need to use this rule, that is sec of 2 pi minus pi by 6, because in fourth quadrant sec is always positive. That will be sec pi by 6, and if you calculate this one, the result will be 11 pi by 6. So sec 11 pi by 6, so alpha plus beta will be 11 pi by 6, that is 330 degree, and alpha minus beta equal to 45 degree. Hence, you just solve those two equations and you will get the value of alpha and beta. Very easy problem then. Okay, then the next problem, after that, the next problem will be 11th problem. 11th problem is very easy problem. ABCD is a cyclic quadrilateral. ABCD is a cyclic quadrilateral. Cyclic quadrilateral. ABCD is a cyclic quadrilateral. Then you need to show that cos A plus cos B plus cos C plus cos D, that is 0. You need to show that too. So, if we construct a circle here, then we are constructing a cyclic quadrilateral here, and that's our, that's our cyclic quadrilateral, and that is A, this is B, this is C, and this is D. And in 10th standard, we have started that angle A plus angle C, opposite angles of a cyclic quadrilateral, are supplementary to each other. So you may write angle A plus angle C, this is equals to 180 degree, and angle B plus angle D is also will be 180 degree. Now the given expression is cos A plus cos B plus cos C and cos D. We all know that ABCD are the angles represented here, and you just need to substitute the value of C, that is C will be actually 180 degree minus A, and D will be actually 180 degree minus B, right? So that will be cos of 180 degree minus A, and that will be cos of 180 degree minus B. Now we all know that that will be cos A plus cos B. Don't need to worry about that one. Cos A plus cos B. So what will be the value of this thing? Cos 180 minus A. We all know that that is minus of cos A. And cos 180 minus B. This is also minus cos B. Because 180 minus B is the angle of angle lying in second quadrant, and 180 minus A is also the angle lying in second quadrant. So that will be minus of cos A and minus of cos B, because in second quadrant cos is always negative. So cos A we are cancelling, and cos B we are cancelling also. So the total result will be 0. Hence proved. That was the problem. A very easy problem and very important problem. Okay. Next we are moving on to the 12th problem. The 12th problem is a solution 4 sin theta cos theta. We need to solve a trigonometric equation here. 4 sin theta cos theta equals to 1 minus 2 sin theta. 1 minus 2 sin theta plus 2 cos theta. Here a restriction has been provided, that is 0 degree less than equal to theta less than equal to 360 degree. That is, we are not going to discuss about general solution. Okay, we need to just go for some special solution. So what will be the procedure here? Very easy procedure. 4 sin theta cos theta minus 1 plus 2 sin theta minus 2 cos theta. We're taking all of them in left hand side and just rearranging them. 4 sin theta cos theta plus 2 sin theta plus 2 sin theta minus 1 minus 2 cos theta, that is equals to 0. What happened here? We have shuffled to 4 sin theta cos theta with 2 sin theta and minus 1 minus 2 cos theta. Now, here we are taking 2 sin theta common. After taking the common, the result will be 2 cos theta plus 1. And in case of this one, minus 1. And the inner part will be 1 plus 2 cos theta. Okay, that will be 0. So the total result will be 2 cos theta plus 1 into 2 sin theta minus 1. This is equal to 0. Now, if 2 cos theta plus 1 that is equal to 0, then what will be the value of cos theta? We all know that cos theta equal to minus 1 by 2 and it is equal to minus of cos 60 degree. Now, in which quadrant cos is negative? You ask yourself. We all know and you also know that cos always negative in second quadrant and in also in third quadrant. So, if it is minus cos 60, you may write this one as cos 180 degree minus 60 degree. That is our cos 120, cos 120 degree and the theta will be 120. Clearly, you may write that one. And if theta lying in third quadrant, because in third quadrant cos is also negative, minus cos 60 will become cos 180 degree plus 60 degree. And that will be also cos 240 degree. And the value of theta will be 240 degree, right? And in case of the other factor, 2 sin theta minus 1 that is equals to 0. And I'm sorry, the second part, last part will be something like, okay, just fixing this one, okay, sorry, 2 sin theta minus 1 that was equals to 0. And in case of that, we know that sin theta equals to 1 by 2. And if sin theta equals to 1 by 2, we all know that sin is positive in first quadrant and in second quadrant. If the angle lying in first quadrant, the value will be very easy, pi by 6. That is 30 degree, sin 30 degree. And theta will be 30, right? And if the angle lying in second quadrant, what will be the value here? The value will be sin theta equal to sin pi minus pi by 6. That is sin 5 pi by 6 and the value will be sin 150 degree and theta will be 150 degree. So the total solution, required solution is in 0 to 360. The result is something like this. Theta equals to, first of all, it will be 30 degree. Then it will be 120 degree. Right. After that, it will be 150 degree. And after that, it will be 240 degree. 240 and 120 came from the previous equation. That was something like 2 cos theta plus 1 equals to 0 sort of equation. And in case of that, you got the result cos theta equals to minus of 1 by 2. And from that relation, we found that theta equals to either 120 degree or 240 degree. And from this equation, 2 sin theta minus 1 equal to 0, we obtained the result that theta may be 30 degree or 150 degree. So there will be total possible solution. Total number of possible solution will be 4, and that is 30 degree, 120 degree, 150 degree and 240 degree. So that's some basic problems from associated angles. I'm going to come with some other set of problems of associated angles. So how's the video? If you are benefited by this video, then just like this video, share this channel and subscribe this one. Okay, and let some comment here. Okay, so that's all for today. Thank you. Ta-ta.